Hi, welcome back. Today I'm going to help you solve some of your equilibrium problems. So this first worksheet is a LeChatlier problem. So it's asking you, this first set, for each of these, would there be an increase of pressure? So when you're looking at this problem set here, what you're doing is you're counting the number of moles of gas. So if you look at A has 2 moles, and then it has 3 moles, right? So if I should get plus pressure, because I have more moles of gas in the product than the reactants. So if I increase pressure, this should be a shift to the left. Since pressure is a product here, if I add more of a product, it should push it to the reactants. Okay, so if we look at the next one, so the next one I have 2 moles here, I have 5 moles here, so this is plus pressure, right? So this should be exactly the same thing. Let me see if I can find one that's different. Alright, so look at C. We'll see. 4, 5, 6, and I have 2. Okay, so I've got pressure here. Right, so I have higher pressure on that side. So if I add pressure, right, I'd be adding it to the side with pressure. Right, so this should shift right. Alright, get it? Okay, so that's the line we have to get. Alright, so coming on down, we keep working with LeChatlier here. So, in which direction would the equilibrium shift in 1A if S2 were removed? Remember, if I remove something, I pull it toward it. So, if I remove this, right, so it'll pull the reaction in the direction of what you remove. So this should be shift right. If you remove products, it produces more products. In 1B, if I remove this, right, so it always moves toward what you remove. So this would shift. Right, so hopefully you get that. Right, you can do the rest of those problems that way. Alright, so let's look down here. So what effect would equilibrium position, a mixture of carbon oxygen, and carbon monoxide, if the total pressure were decreased? So again here, these are all gases. I have 2, 3, and 2. Right, so I have pressure over here. Right, so there's more pressure there. So if the total pressure was decreased, so if I remove this, you should pull it that way. So this would be a shift. Shift left. Okay? So you keep doing all those. They're all pretty much the same thing. Alright, so when we get down here, and you see Kc like this. So Kc is essentially the same thing that we talked about as Kq. So it's the constant of the concentration at equilibrium. So it says the concentration, or the Kc, is 0.020 at 2,870 Celsius. So let's go. Remember, it's products over reactants. So NO squared or reactants is the concentration of N2 and the concentration of O2. That's my equilibrium expression. Right, so then remember, every time you see a bracket, it means concentration. So then you can just start filling it in. There are 0.800 of N2. There's 0.500 of O2 and 0.4 nitrogen dioxide, but that's the quantity squared. So solve that, and you'll get the value, 3 significant digits. Okay, so that's how you solve those kind of problems, those equilibrium problems. All right, so if you come down to the next worksheet, same thing we just did. So this right here, so remember KEQ is the same as KC. It just tells you to fill it out. I think this is exactly this one right here. Oops. This one right here is exactly the same one we did right here. So if you know how to do that, that's all it's going to ask you, is fill those out. Right? So if I fill this out, my KEQ, products of reactants, get my brackets, I'll say my H2O, it's quantity squared because it has coefficient, Cl2, it's quantity squared because it has a coefficient, underneath I get my O2, and my HCl to the power 4. Alright, so that's how you do those. Those are pretty easy. Alright, so down here when you get to 2 and 3 and 4, it's the same as we had up. Right, so just remember, okay, so it tells you here that my Kc is 3O2 for the forward reaction. So remember, if I take the reverse reaction, that kind of stuff. If I take the reverse reaction, right, it's the inverse. So all you have to do is do that. Right, so the reverse is the inverse of the forward. Okay, so that should be pretty easy. And this one right here is solved exactly like this one right here. So if you know how to do that, you'll do it. So set up your equilibrium expression, plug in the numbers and get that. Let's not worry about number 4 because I didn't teach you how to do it yet. Okay. So let's not worry about number 4. Alright? I meant to give you a different number there. I meant to give you number 7. Okay? This one doesn't matter because I'm not teaching you how to do that this year. Alright. Hope you have a good day. I'll talk to you soon. Bye.